Okay, so we chose to perform truss analysis for three separate loading scenarios. The first being with no cars on the bridge, the second being with maximum traffic, which we found to be about 42 cars for this section, and finally with moderate traffic, which we arbitrarily chose to assume about a third of the cars as in loading scenario 2. But before we were able to do the actual truss analysis, there were several things we had to approximate. First of which being the actual lengths and angles of these truss members. So we used the image shown here to basically generate a proportion. So we measured the horizontal distance highlighted in yellow, as well as this first diagonal distance also in yellow, and used a proportion to get the length of that first diagonal member. And we were able to directly measure the angle shown in red, which was found to be about 60 degrees. And with these two combined, we were able to find the lengths and angles of every truss member which we wish to analyze. And the next thing we had to do was approximate the weight of the bridge. So once again, as we show in our calculations, we used the dimensions that we found along with the density of concrete to give it an approximate volume for the entire bridge section as well as the section that we're analyzing, and this allowed us to determine the weight. And the next thing we had to do was approximate the weight of any cars which we wish to take into account. And we used a similar strategy to approximate the weight of the cars for the different loading scenarios 1, 2, and 3. The next thing we had to do was approximate the vertical loads that we applied to the bridge. And our general strategy was to take the weight of the section and the cars for the three different loading scenarios and split them evenly across the four lower joints which you see in this image. And finally, the last thing we had to do before we were able to begin with our analysis was approximate the vertical force AY shown here. And we used a similar strategy for each loading scenario where we took the total weight of the bridge along with the weight of the cars on the entire bridge and split this load evenly across the four support pillars which hold up the entire bridge structure.